Mutate a list and whatever it held a moment ago is gone. There's no undo. But Python gives you one small piece of syntax that makes a genuine copy first, a brand new list object holding the same elements. In this video, we built that clone, watch it show up in memory as a second independent object, then use it to write a function that empties a list and refills it in place. Working with mutable objects has one persistent inconvenience. The moment you mutate a list, whatever it held before is gone, and nothing in your program remembers it. Plenty of problems need both versions, the list as it is now and the list as it was. The fix is to make a copy first. Then you can mutate the copy while the original stays intact, or mutate the original and still have every old item saved somewhere else. So ask Python for a copy. Behind the scenes, it creates a brand new list object in memory and copies over every single element from the list you're copying. The syntax is a pair of square brackets with a colon inside them. Suppose you already have a list named L, you write L, then square brackets with a colon inside and assign the result to L copy. Python builds the new list in memory first, then binds that new list, which has exactly the same elements as L, to the name L copy. The colon with nothing on either side means from the beginning all the way to the end. Here's what that looks like in memory. Name the original list L original, holding 4, 5, 6. The name is arbitrary. Calling it L original rather than L just shows that you reference whatever your list actually happens to be called. Write L original followed by square brackets with a colon inside and bind the result to L new. That copies every single element from beginning to end into a fresh object. Now look at memory. There are two list boxes, not one, reached by two different names. Change one of them and the other doesn't change. Set the first element of L new to 99 and L new becomes 99, 5, 6, while L original still holds 4, 5, 6. They're completely separate objects. Now put that clone to work. Write a function called removeAll, taking a list L and an element E. Last lecture, a similar function created a brand new list, filled it with every element of L except the ones equal to E, and returned that new list. This version doesn't create and return anything. It mutates the input L so that afterwards only the elements that do not match E remain. 3 steps get you there. First, save the list as it currently stands into a copy. Second, empty out the list you want to mutate. Third, walk the copy and add back into L every element that does not equal E. We write def, then remove all, taking L and E. Say L holds 1, 2, 3, 4, 3, and E is equal to 3. First line inside the function, initialize a new list to hold the copy. L new is set to L, square brackets, colon inside. Copy first because we want to mutate L, and L already contains a bunch of items. Copying saves everything L currently holds into a separate list named L new. Second line, L.clear with nothing inside the parentheses. Clear takes no argument. It simply empties L completely, dropping every single element. After that call, L becomes the empty list. The object still exists in memory at the same place, holding nothing at all. Watch the diagram. L new still has all the data and L is now an empty box. Third, add back the elements that satisfy the condition. We iterate over the list that actually contains the data, which is the copy. For n in L new, then if n is not equal to E, append n onto L. Notice the asymmetry there. We append to L, but we iterate over L new. L new is the one with all the elements in it. We touch each element to see what value it has, and if it isn't equal to the parameter E, we append it onto L, the list that's currently empty. Follow the trace. 1 is kept, 2 is kept, the first 3 is skipped, 4 is kept, the last 3 is skipped. L ends up holding 1, 2, 4. This function has nothing to return. It wouldn't hurt to return L, but L has already been mutated by virtue of running the function. L is the parameter that was passed in, and the caller is holding that very same object. so there's nothing worth handing back. The function simply ends after the loop, and the Python returns none. That changes how you call it. Make a list named len holding 1, 2, 3, 4, 3. Then call remove all, passing in len and 3 on a line of its own. Don't save the result into anything because the result is none. The real work happened to the object you passed in. Print len after the call and you see 1, 2, 4. The list you handed over came back changed. Run the other two examples. Start with a list holding 1, 2, 1, 2, 1, and remove all the ones. Every element equal to 1 fails the test and never gets copied back. So what returns is a list of all 2's. 2, 2. Now start with a list holding 1, 2, 3 and remove all the zeros. There's no 0 anywhere in that list, so every element passes the test. All 3 survive the trip through the copy, and the input list comes back holding exactly what it went in with. 1, 2, 3. Same object, same contents. 3 things to carry away. Square brackets with a colon inside copy every element into a brand new list object. So the copy and the original are 2 separate objects in memory, and the mutating one leaves the other untouched. To rewrite a list in place while still knowing what it used to hold, clone it, clear it, then append back only what you want to keep. And the function that mutates its argument has nothing to return because the caller is already holding the object that changed. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.